Hello everyone, myself Bandgar working as an assistant professor at Department of Physics, KTCM College, Nasa. Today we have going to discuss M.Sc second year semester 3 paper 3 experimental technique in physics first. Today we have to cover up the first module signal analysis and sensors. We have to cover in this video the subtopic of classification of sensors, part 3, and dynamic characteristics of sensors. First module is signal analysis and sensors. So last lecture we have to see or started the classification of the sensors. So we have to see the 5 types of sensor is based on second one primary and secondary, third one is the analog and digital, fourth one is the active and passive sensors, and last one is the sensors and its inverse operation. So in this video we have to start it with the second type of sensors. So it depends on the working function, that is the primary and secondary. So mechanical device converts physical quantity to be measured a mechanical signal. Such mechanical device are called as primary transducers because they deal with physical quantity to be measured. So primary sensor means whatever physical quantity you have to sense and convert it into some signal, that is the mechanical signal, is known as the primary signal. Second one is the electrical device that convert mechanical signal into a corresponding electrical signal. Such electric device is known as the secondary sensor or secondary transducer. For example, a Bourdon tube acting as a sensor, which senses the pressure and converts the pressure into a displacement of its free end. The displacement of the free end moves the core of a linear variable differential transformer. LVDT as a secondary sensor which produce an output. So Bourdon tube, it senses the pressure converted into a displacement, and LVDT, it senses the displacement and converted into a output voltage. So Bourdon tube is the primary sensors and LVDT is a secondary sensor. Next type of sensor is the active and passive sensors. So active and passive sensors is depend on what type of components used in a sensors, which gives the subtype of active and passive sensors. So starting with the active sensors, it doesn't require any external source of power their operation. So that's why it is called as a self-generating type transducer. It operates under the energy conversion principle. So their operations performing the principle of energy conversion. So two examples, thermocouple and thermopile. A EMF is generated across the junction of two dissimilar metals or semiconductors when junction is heated. So when thermocouple is heated, there are two junctions, so there is EMF generated. So that is the function of the thermocouple or thermocouple. So mostly they are used for temperature measurement, heat flow measurement and radiation measurement. Next, second example, piezoelectric effect. So here a EMF is generated when external force is applied to certain crystalline material such as a crystal, sound, vibration, acceleration and pressure change. So here EMF changes because of some vibration, acceleration and pressure change. Next, second type of sensor is the passive sensor. So it needs the external source of power, their operations. So these are the passive components. So that's why they require an external power source for operation. So they are not self-generating type transducer. So here a DC power supply or audio frequency generator used as a external power supply. So when they are operating, they require some power source. So these transducer produce the output signal in the form of variation in electrical parameter like resistance, capacitance or inductance. So it has some examples like as a thermistor, potentiometer type transducer, like as a resistive, capacitive or inductive. Clear? Next type of the sensor is the analog and digital. So here what type of input signal or output signal, so it decides the type of or classification of the sensor. So when we use a analog sensor or digital sensor, so analog transducer, it converts the input quantity in a analog output, so which is a continuous function of time, or it is the varying with a time. So analog sensor which is gives the output in terms of analog signal. So that's why that is the known as the analog sensor or analog transducer. For example, like as a strain gauge, LVDT, thermocouple or thermistor. So these are the examples of the analog sensor or transducer. Second one is the digital transducer or sensors. So these transducer converts the input quantity into a electrical output which is in the form of pulses. So its output is, or that pulses is represented by 0 and 1. For example, a glass scale can be read optically by means of a light source, an optical system and photocells. So these are the examples of the digital transducer or sensor. So digital transducer, their output is always in a digital form, like as a square waveform, pulses or in a digit. So that's why that is the known as the digital sensors or transducer. Next, fifth type of the sensor is the sensor and sensor inverse sensor. So this type is indicate the operation of the sensor. So here most of the sensors are sense the physical parameter and converted into a electrical form. Means non-electrical quantity are sensed or given to the output in terms of electrical, but some of the sensors are like as a sense the electrical output and converted into a non-electrical form. So that is the operations of the sensor and inverse sensors. So sensor, it converts non-electrical quantity or non-electrical parameter or physical parameter converted into a electrical quantity or electrical form. Example, resistive, inductive and capacitive transducer. So these are the transducer which are sense the physical parameters or physical quantity or non-electrical quantity to convert it into a electrical quantity. Next, inverse sensors. It converts electrical quantity to an non-electrical. So already we have to seen what is the inverse sensors. It converts the electrical form to a physical form or physical parameter or non-electrical quantity. For example, we have to know everyone a piezoelectric crystal. it acts as inverse transducer, because when we apply voltage across its surface, it changes its dimension, causing a mechanical displacement. So here electrical quantity or electrical voltage given to that sensors, and which gives the displacement. So here electrical quantity converted into a non-electrical quantity means which gives to the electrical input and converted into a physical output in terms of the displacement. Next parameter is the dynamic characteristics sensors. So dynamic, we have to know the changing. So we have to know the word, what is the dynamic. Dynamic is the changing, not stable, not constant. So we have to already seen the characteristics of the sensor is a static. So that is the stable, constant, and gives the desired stable output. But dynamic characteristics of the sensor, which are the not stable, not constant, so there are changes with respect to time. So here input are changes, so output are changes. So dynamic characteristics of the transducer is related to its performance when measured quantity is a function of time. That is, it varies rapidly with respect to time. While static characteristics relate to the performance of the sensor or transducer when measured quantity is essentially constant. The dynamic characteristics relate to dynamic inputs, means changing input way, which means that they are dependent on its own parameter as well as nature of the input signal. So which means that they are dependent on its own parameter as well as nature of the input signal. The following are some dynamic characteristics that may be considered in a selection of transducer. First one is the dynamic error, second one is the fidelity, third one is the speed of response, fourth one is the measuring lag. So overall, both static and dynamic characteristics of transducer determine its performance and indicates how effectively it can accept desired input signal and reject unwanted inputs. So starting with the first dynamic characteristics, dynamic error, the difference between the true value of the measured quantity to the value shown by the measuring instrument under varying condition. It is the difference between true value of the quantity changing with time, the value indicated by the measurement system if no static error is assumed is called as measurement error. A measure of the inability of a system or sensor to be adequately reconstruct the amplitude of the input for a particular frequency. So dynamic error is the difference between a standard value and measured value is varying with a time. So that is the known as the dynamic error. Next one is the fidelity. So fidelity means how much input are given and how much output is occurred with related to the input. So then we say if output is occurred is related with the input, then such fidelity is good. When it is not occurred, then we have to say fidelity is the not good. So it is defined the degree to which measuring instrument is capable of faithfully reproducing the changes in input without any dynamic error. So when we generate the output with related with a varying with a time as an input, then we have to generate very stable output or desired output without any dynamic. So fidelity means it is the ability of the system to reproduce the output at the same as the input. So then we have to say the 100% fidelity of the instrument or of the system. Next, speed of response. The third dynamic characteristics of the sensor is the speed of response. It is defined as the rapidity with which a measurement system responds to changes in the measured quantity. So when we given to the input and how much time required for to generate a output, so that time is as minimum as, then we have to say the speed of response of that instrument is good. So it can be defined as the time which passes after a sudden change in measured quantity until the instrument gives us different reading from the true value. So it indicates how active and fast the system is, means indicates how fast the sensor's measurement system reacts to the changes in the input variable stepping. Means when we given to the input to the system or measurement system, then how that system is operate or gives the fastest output at the output, then we have to say the speed of the response of that measuring system is. Next, last dynamic characteristics of the sensor is measuring lag. It is the time to respond to that particular instrument when we change the input. This time is known as lag. Whatever time required for a measurement system when we change the input, that time is known as the lag. So every system take at least some time to respond. Whatever time it made to be the changes in the measured value. For example, lag occurs in temperature measurement by temperature sensor such as thermocouple or RTD or dial thermometer due to scale information on thermo well due to process liquid. So we have to see some example, thermocouple or RTD or thermodial. So when we temperature measurement by a sensor to scale formation on the thermowell due to a process of liquid. So we have to lags are two types. First one retardation lags and second one is the time delay lag. So retardation lag, that means when we change the measure quantity, the instrument also changes its value in the faster way. The response of the measurements being immediately after change in the measured quantity has occurred. So where we have to change the input quantity, so after immediately we have to get the desired change in a output or change in a response of the measurement system. Second one is the time delay lag. So here response time is slow when we changes the inputs. So time delay lag means the instrument changes its value after some time when the measured quantity changes. In this case, the response of the measurement systems begins after a dead time after the application of the input. So here some time is required when we changes your input, and after some time changes their outputs.